In the last set of example, I call these bonus example. The purpose of these is to show you an alternative technique to getting your standard equation into vertex form. We haven't needed to use this technique. It's called completing the square because the quadratic formula already has completing the square built into it. So you don't have to do it. It's already done. And the vertex form already has completing the square done, so you don't have to do it. It's already built into it. But let's say that you forget the quadratic formula, or you forget the formula for h equals negative b over 2a. There is an alternative, and it's all algebra based, and it's based off of a very simple concept called the creative zero. I'll write that up here. The creative zero. Let's dive into an example here. Part A. F of x is equal to x squared minus 2x plus 3. First thing I'm going to do is I'm going to insert a 0. F of x is going to equal x squared minus 2x plus 0 plus 3. I'm going to use a different color on these examples just so we can see where the creative zero aspect of the completing the square process comes in. So I'm adding 0. You can always add 0 to an expression because it does not change the value of the expression. Now here's the creative part. So I'm going to take that 0 and I'm going to represent it as a +1 and then a -1. And then I'll have my +3 there at the end. So the +1 -1 is the same as 0. That's the creative 0 part. Then what I'm going to do is I'm going to take the first part of my creative 0 and I'm going to group it with the first two terms. Now x squared minus 2x plus 1 represents what's called a perfect square trinomial. And perfect square trinomials are special because of how they factor. They will always factor into the same factor twice. In other words, x minus 1 times x minus 1. Outside of the grouping symbol, I still have -1 plus 3, which are just constants. There's no variable involved at all. Combine them together and you have +2. Now because you have the same factor here twice, you can simply write it as x minus 1 squared plus 2. And if we've done this correctly, we should be able to identify A, H, and K. A would be 1, H would be 1, and K would be 2. So we're able to take standard form and turn it into vertex form by using this complete the square process, which involves a creative 0 and also perfect square trinomials. So this is what I would box in as the vertex form for this function. Now, the big question is, how do you get the creative 0? I chose +1 -1 for the creative 0. Could I have done +2 -2 and this still have worked? And the answer is no. You have to choose the creative 0 that's going to force a perfect square trinomial to exist. So there is actually a way that we can calculate that. If you take the value of b from the original equation here, if you divide that by 2 and then square it, you'll get -1 squared, which gives you +1. This tells you what to use for your creative 0. There are going to be a few other examples of this, so we'll get a chance to see how this creative zero works with other functions.